Insertion sort is another comparison based sorting algorithms like merge sort, selection sort, quick sort. So these are all comparison based sorting algorithms. Till now, whatever algorithm we have discussed, these are comparison based sorting algorithms. Okay. So how insertion sort works? It works similar way as we sort the cards. Okay. So it works similar way as we sort the cards. Let's say we have a card like 1, 5, 6, 2, 3. Okay, so if you want to place 2 in its right position, so what you will do, you will put it here just after 1. Okay, so the similar way insertion sort works. So we will discuss it in detail. Now the next point is, it is in place sorting algorithm. What does it mean? It means that we don't need any extra space to sort the array or to sort our data structure. Okay, it is stable sorting algorithm, right? So let's say we have 1, 2, 2, 5, 3, 2. So the sequence of repeating element will be remain same. Okay, the sequence will not change. So it is in place, it is stable, and it can be used when the number of elements are less, and also it is in almost sorted order. So we will see how these points are valid. So let's start with our first example. So let's say we have element like 1, 3, 5, 6, 2, 4. Okay, so take these elements only. Now if we are at 1, so we will see whether the 1 is it in correct place or not. So we are at first position. Okay, so this will be in correct place, right? Because no elements before 1 is there. Okay, so 1 is sorted. Now come to next index. Check 3. Is 3 in its correct place? So to check if it is correct place or not, check in the previous positions. So compare 3 with 1. So 3 is greater than 1. That means 3 is in correct position. Okay. Now let's move further. So check 5. Compare 5 with previous elements. Okay. So if 5 is greater than 3, that means 5 is in correct position. We are comparing 5 with 3. So 5 is in correct position. Now we don't need to compare it with 1. Why? Because we are sorting from beginning. Okay, so if 3 is in correct position, which means before it all the elements are in correct position. Okay, so we compare 5 with 3, and we will keep on comparing until we get its correct position. So 5 is already at correct position, so we don't need to change. Now come to next position, that is 6. Okay, so 6, compare 6 with 5. Compare 6 with 5. So 6 is greater than 5. That means 6 is at correct position. Right? Now move to next element. So next element is 2. Now compare 2 with 6. So 2 is greater than 6? No. That means 2 is in not correct position. So swap this with this. Okay. So let's swap 2 with 6. So that will be 6, that will be 2. Right? Now further what we will do? We will again check if this is in correct position or not. So check 2 with 5. So it's still not in correct position. So what we will do? We will swap 2 with 5. So this will be 5, this will be 2. Now again check 2 with its previous element. So 2, compare 2 with 3. So 3 is greater than 2. That means 2 is still in not correct position. So swap 2 with 3. So 2 will be here, 3 will be here. Now again compare 2 with 1. Okay, so compare 2 with 1. 2 is greater than 1. That means 2 is in correct position. So no need to swap. Okay, so at max we will compare till here, right? So at max we will compare till here. So from here we will compare our previous element. So in the back side we will start from our current position and we will keep on comparing and swapping until our current position is greater than 0. That means till here. Okay, So till here we will compare 2 with 1, right? So that will be our last comparison from our current index. Okay, so what the array looks like after swapping? So it will be 1, 2, 3, 5, 6, right? And we were at this position, and 4 also. So currently we were at this position, right? So till here all the elements are sorted. Till here all the elements are sorted. When we are at current position, so previously all the elements will be in sorted order, right? If not, then we will sort. So move to next index. Our next element is 4. So compare 4 with 6. So 4 is less than 6. That means 4 is not in correct position. So what we will do? We will swap it. So swap 4 with 6. So we will swap 4 with 6. Now again compare 4 with previous element. So we will keep on comparing until our previous element is less than our current element, right? So compare 4 with 5. Again, it is not in correct position. So what we will do? We will swap. So it will be 5, it will be 4. Now compare 4 with 3. So compare 4 with 3. 3 is less than 4. That means it is in correct position. So we will get out of the loop. So after this, our array will be looks like 1, 2, 3, 4, 5, 6. And further, no element is remaining. So we have sorted all the elements, right? What we are doing? We are checking at current position. At current position, we are comparing with all the previous elements. So what we are doing? We are checking. We are comparing our current element with previous element. We are comparing our current element with previous element. Okay. And we are keep on comparing until it gets the right position. We are keep on comparing until our current element will be at right position. Okay. So we will run 2 loops. First for this outer loop, right? First for iterating these elements. And second loop to compare with previous elements, right? Second loop to compare with previous elements, right? Okay, so let's write our pseudo code. So we will take a loop int index equals to 0. It will run till n minus 1, where n are the number of elements, and it will keep on incrementing. So that is our for loop. It is our outer loop. We know how to write for loop, right? So inside it, what I will do, I will take let's say a variable correct position, okay, and I will take our index inside it, assuming we are at correct position. So element at our current index is at correct position, okay. So inside it, what I will do, I will take a loop, right, and I will run our correct position greater than 0, because what we are doing, we are comparing our current element with our previous element. So it should be greater than 0, right? Because it should be at second place. So let's say we have an array 2, 3, 1, 5, 7. Okay. So if I am at this position, what I can do? I will compare this with this. I will compare this with this, right? So first it will be 3, it will be 1. Okay. Then I will compare 1 with 2. So it will be at 1 index, it will be at 0 index. So we will compare till here, right? This will be our last comparison. So we can compare only when we have previously at least one element. So we will take our correct element greater than 0. Okay. So, and it will be array at previous element, right? Correct minus 1. It should be greater than our correct element. So we will keep on comparing until this condition satisfied, until our previous element is greater than our current element. Okay. So what I will do, I will keep on swapping. What our previous element and our current element. So our current element is this one, right? So we will keep on swapping. Now after this I will decrement it, right? So I will decrement it. So this is our pseudocode, and what we are doing, we are checking on previous indexes whether the previous index is the correct position or not, right? So we'll keep on checking. So this will be our inside loop. Okay, so let's code it quickly. So this was our selection sort program. Let's write it as insertion sort. Okay, and let's call our insertion sort here also. So this was our outer loop, and here what I will do, I will take a variable of correct position. So initially our correct position is I. Now I will run a loop while my correct position is greater than 0 and array at previous index is greater than our current index. So our current index is CORR. Now what I will do, I will call the swap function. Okay, so we have already created swap function. So I will pass this array at what, my previous position, comma, array at my current position. Okay, and I will decrement it. So this will be our code for insertion sort. Let's save it and run it. 24571. Okay, so it will be run till 0 to n minus 1. Okay, let's save it and run it again. Yeah, 12457. Okay, so we will run a loop from 0 to n minus 1. So this was our code for insertion sort. Now what will be our time complexity? So our time complexity will be this loop will run for order of n times. Okay, so order of n, and this loop, how many times this loop will run? So let's say our array is almost sorted. So let's take 10, 20, 30, 40, 50. Okay, so in this case what will happen? It will not go inside our inner loop, right? It will not go inside while loop. In this case 20 is greater than 10, so it is already sorted. Now move to next index. 30 is greater than 20, so it is at correct position. Now move to next index. 40 is greater than 30, so it is at correct position. Now 50 is greater than 40, so 50 is also at correct position. So what will happen? In best case we will have 0 swaps equals to 0, and comparisons, how many comparisons we'll have? So in first case we will have 0 comparison. Okay, then we will have 1 comparison, then we will have 1 comparison. Okay, till n. So in best case what will happen? There will be n comparisons, right? Every time 1 comparison. Now let's take the worst case. So in best case our time complexity will be order of n, right? Best case it will be order of n. Now take worst case. Worst case will be n for our outer loop. Now let's take reverse of this. 40, 30, 20, 10, right? So first time inside loop will run for 0 times. Okay, second time 30 will compare with 40, so we'll do a swap. Okay, so we'll do 1 swap. Now next 20, so after swapping this will be 30, 40, 20 and 10. Now come to next index. So 20 will compare with 40, 20 will compare with 30, so it will run 2 times. Okay, so after comparing we will do swap, so it will be 20, 30, 40, 10, right? Now come to next index. So our next index is 10, so 10 will compare with 40, 30, then 20, so we will have 3 swaps, and while loop will run for 3 times. Okay, so and so on. What will happen? At worst case, in nth time the comparison will be n and the swaps will be n. Okay, so in worst case it will run for the total. We know 1 plus 2 plus 3 plus 4 plus 5 plus till n will be n into n plus 1 by 2, right? So this will be nothing but order of n square. So in worst case it will be order of n into n, right? Now in worst case, what will be swaps? The number of swaps will be same, order of n square, right? And number of comparisons will be n square, right? Every time we will comparing, every time it will be swapping. So what will be our time complexity? In best case it will be order of n, in worst case it will be order of n square. In average case also it is considering as order of n square. Okay, so this was our time complexity. And space complexity, we are not using any extra space, so it will be order of 1. Okay, so let's revise it quickly. In best case, insertion sort is order of n time, and the number of comparisons it will take n minus 1, right? Because if there is only one element, then how we will compare? So we will compare n minus 1 elements. And if the array is almost sorted, then insertion sort will take order of n times, right? We have seen 10, 20, 30, 40. Okay, and the number of swaps are equals to number of inversions, right? So the number of swaps we have discussed. In best case it will be 0, right? There will be no swap. So 10, 20, 30, 40, there will be no swap, right? In worst case, the number of comparisons and swaps will be order of n square, right? Because first time we will compare 1, then 2, then 3, then 4 till n minus 1. So it will be nothing but n minus 1 into n by 2. So it will be almost order of n square. And in average case, let's say half elements consider best case, half elements consider worst case. So it will be order of n square. So insertion sort is good for best case only, when the array is almost sorted. So there is one more way to write insertion sort. So if you want to do this, you can follow the notes I have already shared in the previous lecture. So in that note I have shared that another method, so you can follow that one also. Okay, so this was all about insertion sort. Okay. So if you want to refer the notes of this lecture, so you can scan this QR and you will get the notes of all the sorting algorithms. In this notes we have covered insertion sort, selection sort, bubble sort, heap sort, merge sort, quick sort in detail. Okay, so if you have any doubt, you can read these notes. And this was all about this lecture, and